This is an example of a cable robot that has 3 actuators. So the layout of the cable robot is like this. This is the top view. So there are 3 joints. There's J0, J1, and J2. And they each have a cable that runs down to point P. So by changing the length of L0, L1, and L2, P can move anywhere within this triangle. The dashed line represents the work envelope. And not only can it move in 2 dimensions, but if you look here, if you were looking at the side of the cable robot, J0, J2, and J1 all lie in a plane, and then those lengths go down to point P. And having 3 different cables, there's only one singular solution to the problem. There's actually 2. There's one down below the plane, and then there would also be one up above the plane, but the software ignores the one. It only works below the plane because we can't push on cables and get the point above. So that's the concept of the cable robot. And then over here you can see this would be J0, and it's just a stepper motor, and then there's a cable drum that sits up in there, and then the length, you can't see it really because it's fishing line, but then that runs down, and here's point P, and there's little flags. This would be L0's cable. There's little flags when you look at the video later on. So over here we have L2, or excuse me, J1. So J0, and then we go straight across to J1, just like we do right here. And then if you come back over, here is J2. And then these orange lines right here represent the work envelope, and they were just used to allow me to get it all planar and figure out what the distance is between the points J0, J2, and J1. Because you have to program all that into the kinematics so that the computer can figure out how what distance it should make L0, L1, and L2. And then here is the point P. So let's see this in action. It runs on G code. So here's our G code right here. So what's going to happen is the tool is going to start up at 0, and then it's going to go down 56 inches, and then it's going to go and move around in a 12-inch circle, and it's going to do that several times. So let me click go here. So the tool is starting to go down at the moment. And the tool goes down kind of slowly for this because it's used to running the CAM program that's used to generate this has limits on how fast the tool can plunge, just because you don't want to plunge your mill into a piece of aluminum too fast. But it's almost there. It's got 1 inch to go, so there it hit it. So now it's doing the 12-inch circle, and you can see it flying around here. And that little hesitation is where it goes down. It's programmed to go down 1/10 of an inch. So it drops down 1/10 of an inch, and then it keeps going on the circle. But I don't know if we can get a good viewpoint of it here. So all the cable lengths are changing simultaneously in order to make this circle. And it's actually quite impressive because point P is moving at a constant velocity around this circle. And I can see what that is over here. It's going at 240 inches per minute. I don't know if I can increase it from that or not. Let me see if I can. No, that's all I got at the moment.